Hi, everybody. Apologies for being slightly late there. But yeah, it's Jonathan Ridley here from JBUS. Today we're going to be discussing Falcon 2, the new Falcon methane detection TIDLAS system. I'm pleased to have Alexei with me today from SPH Engineering, who is going to be running through Drone GIS at the end and giving us a good idea of how Drone GIS is kind of changing the game or helping with methane mapping and making sense of the data effectively. We'll kick off. I know we're slightly couple of so hopefully everybody can see this screen now. Can everybody just confirm that you can see the screen? Yeah, okay, cool. So just a bit about the webinars, what we're going to talk about today. So we're going to a little bit about JBUS. We're going to have a just quick look at methane and some data from base. Look at the core components of the Falcon system, how it's set up and configured. We'll then look at some how we access the data, how we validate and maintain some the quality. And then there's going to be a little bit of detection and mapping today in regards to what we can do with the system today versus the ideal, which is to have some kind of quantification or what many in the scientific world call a flux calculation, which should be coming tomorrow, quite soon actually. And then we'll just quickly look at JBUS's supply, and then Alex is going to take us through Drone GIS, so that'd be good. Ending with the Q&A. Like all these webinars, please send your questions in, and yeah, we'll try and get them answered as we go through. If not, we'll answer them at the end. But yeah, either way, we'll get them sorted. If, as I always say, if there is something that you need answering, then we don't cover it, then please, by all means, send it in afterwards. It's no problem. We'll get back to you. So, okay, so a little bit about JB Unmanned Aerial Systems. As you're probably all aware, we are very close partners with SPH Engineering, who are they produce this complete Falcon integrated system with a drone. The OEM themselves who create the laser itself that does the measuring is by Pergam Swiss, and SPH Engineering and Pergam have been working together for a very long time on this kind of technology. And yeah, we just make up that triangle. So trying to get this sort of technology more widely known in the marketplace, and hopefully by doing so, you know, we can help everybody in this whole game, of this climate change game that we've got. Well, I say game, it's a very serious game, but yeah, try and help everybody. So let's look just a little bit about JBUS and kind of the sort of systems that we do. So we're not just selling methane laser systems and training people on laser systems. We're also looking at other systems like metal detection. A lot of people will know that we do a lot of work with magnetometry, as we sit with Census. We're also started to do work with GPR systems and a number of applications, so that's really good. And echo sounder and sonar systems, we've recently done quite a lot of trials of these systems, and also talking to a number of construction companies and of how we can use the echo sounder. And lastly, thermal systems. Yeah, people will be aware that we work with Workswell, and we do cameras for inspections, pipeline surveys, and also agriculture as well. So just a little bit of an overview of what we're doing. Yeah, and if any of these are of interest to you, then obviously get in touch, info@jbus.co.uk, or just go to our website, www.jbus.co.uk. So yeah, being a bit of a geek, I wanted to sort of give a little bit of an overview on where we are with methane. I know that we're in our bubble sometimes, but a lot of you will be aware that methane, its kind of global warming potential is quite significant. And over a 100-year period, it's 28 times more powerful than CO2, and then over a 20-year period, a shorter period of time, at 84. So anyway, the main thing here is just to say that methane is we shouldn't forget that methane has got a high global warming potential, and it's something that we need to restrict in terms of our emissions of it. A kind of overview there from a base report from these figures here, million tons of CO2 equivalent, but you can see here globally, just for information, that it's it's going in the wrong direction. In terms of the UK, we've been very successful. I must admit, in terms of reducing methane, both in oil and gas or energy, and also waste and agriculture. I think are also now looking at ways that they can reduce their emissions. I know over the last landfill or waste, they've reduced their emissions significantly because of all the work they've done on capturing that landfill gas and generating electricity. So that has been a success story. But still, the two main areas that I think that we can really still make a difference in regards to helping these companies with their walk downs and their statutory surveys and readings is in agriculture and in the waste industry, not just from landfill, but also so obviously water as well. So it's an area that there's plenty of potential to go at, and ways at which we can we can help with this kind of technology. I just wanted to put this up because this is quite a recent thing. It was talked about quite a while ago, but it's now really coming to fruition, and that is the Environment Agency's methane action plan. And what this is a really good thing. They've started to introduce best available technology approaches, and also they're looking to rightly, I suppose, to look at regulating certain technologies that are really going to help with what they've got to achieve. So that is something to bear in mind, that the Environment Agency now are really stepping up their efforts to reduce our methane emissions. So let's look at the Falcon. Look at the core components of the Falcon. So as we can see here, there are a number of components, but the main ones I'll go through the hardware ones first, and then we'll cover the software side. But we have the Falcon laser, of course, which is the system that is actually sending the laser out and then is reading what comes back and giving us that parts, giving that reading parts per million. We've got SkyHub, which is taking that data and fusing it with telemetry. We've got the TTF radar on the bottom left-hand corner, which is enabling the drone, once it's taking this data and recording it, to be kept at a specific height above ground, which is really useful for the way that we record the data. And then the software side of it, what is missing from there is there's the drone, but I'll come on to that in a minute. That's a very important part. But the software side of it is there's three main bits of software that it integrate seamlessly. There's the ground control software, what people would know as UGCS, which is where do you want the drone to go and where being in terms of its route. We've got a companion Android companion piece of software that fits on your controller for DJI drones like M350, M300, and M350, and that would be like your DJI Go, that kind of thing. And we also have the custom payload monitor, which is where we which our interface, if you like, into SkyHub and seeing data come in and so on, and be able to download data set height above ground, so that these three bits of software work together. But when we combine it with the drone, it's kind of looking a bit like this. You'll have to excuse me, but this is an older SkyHub 2, but it doesn't take away from the actual look and feel for what you would expect on a standard commercial DJI drone, like this particular one called the M300. You can see that we have the SkyHub, we have the Falcon, We have the cables connecting, the OSD cable coming from the drone that's bringing in the telemetry and the power to the Skyhub, which is then passing it on to the Falcon. And you can down in the bottom right-hand corner, you can see the radar altimeter. So that's sitting just below the leg there, and that's looking to keep the height at the level that we want it to be, let's say 15 meters. So that's what you'd expect to see. The only thing that isn't on there, actually, which we will talk about a little bit later, is the anemometer. And I'll look at the anemometer, if I can say it, a bit later on, because that has an important part in the future. We can cover that. We can cover that later on. So I've talked about Skyhub, which is a really important part. Skyhub is essentially, for DJI drones, it's the system that implements the true terrain following. So where, in this case, we're flying Methane, but we want to keep the drone at a certain height above ground. The radar is taking readings, so many times a second, and it's making sure that the drone is kept at that height that you require it to be, which is, like I said before, the way that we take the data, it's quite an important element. It's also taking the data from the Falcon into the system, and it's then fusing that data with the UAV telemetry. So when we get the data, in from the Falcon, we take the data from the telemetry data from the drone, which, if it's RTK georeference, for example, and we then fuse that together to create the CSVs and the other log files that we'll talk about later. Well, which we'll just talk about to the bottom. Yeah, and I mentioned it before, and I put it in again here. The new I don't think I've spelled that right, but anyway, the anemometer, the new version from FT Technologies, which we will be using on future drones. My understanding is it's being able to provide air pressure, wind, speed, and direction. And using, and we'll probably touch on this a little bit later when I talk about the anemometer. Then SPH Engineering have done some clever mathematics and have come up with a way of actually showing that data and getting it in a form that it can be used by algorithms such as those that will be coming up in the future to do special things with this kind of data. So you can see what it looks like. There's the Skyhub in general has lots of different connections. We don't just connect in Methane, Falcon. The Skyhub is what is part of what's called a core system, and we're able to connect in different sensors. So we can take the Methane sensor off. If we wanted to, we could attach a GPR, or we could attach an echo sounder for getting bathymetry of a river, let's say. And we would just do a few changes to the actual Skyhub itself, and we would be okay to go. So it's a very versatile system. Once you get the core kit in place, it's essentially about putting different sensors on and just changing a few things. Very easy to use, very good. So that's Skyhub. Radar altimeter. Why do we use radar altimeter? I mean, a lot of you who fly drones will know barometric pressure can't be 100% trusted, but also we need to meet the needs of the sensor. So in this case, the Falcon is, and we'll touch on this a bit later, is reading data in reading in ppm times m. That's parts per million times meter column. And because of that meter column, we need to maintain that height above ground as precisely as we can. With the radar system, with the TTF system that we have, in ideal conditions, you shouldn't see it fluctuate more than plus or minus 5 centimeters. Sure, when I've been out and about flying true terrain following in good conditions, it's holding its own within a few centimeters in a lot of cases, which is very, very accurate. And so, yeah, that's a really good reason to have TTF, is that you can maintain that height very accurately. The other thing that I will mention it, and some of you might get involved in other sensors as well. For example, echo sounder. There are other algorithms or other flight modes that you can have. One of which is grasshopper mode. and it uses it relies on the true terrain following radar and feature. Grasshopper mode is a very clever system that allows you to fly to a location, drop the drone to do a task, drop in and come back up, and then go to another place and drop down. And so it's a really clever bit of programming, and that comes as part of the true terrain feature. So yeah, that's why we have the radar altimeter. So the next on the list is the Falcon 2 itself, the TIDLAS system. I'm sure I've got that written down somewhere, but turnable diode, I think it is. Spectroscopy, I think it is somewhere in there as well. But yeah, these are some specifications of it. No false readings from this system. It's only designed to see methane, so you don't need to worry about whether you've detected methane or not, because it only detects methane in the column. So yeah, it's quite foolproof in that regard. Sensing range 1 to 50,000 ppm. We'll get into it's a bit more its capability in a minute. Detection distance up to 100 meters. Ideally, as I say at the bottom here, recommended flight altitude 15 to 30 meters above ground to get the best results. Yeah, with a payload of 1 kilogram, and I'll show this a bit later, you get good flight time. Recommended flight speed 2 to 4 meters a second. It's down to personal choice, but that's what's recommended. We can talk more about that afterwards. If you've got any questions on that, please send them in. Continue with the specifications. Do we have real-time data transmission? The answer is yes, we do, with using UGCS SkyHub and the CPM interface. So I'll show you a picture of that a bit later on. Geotag data, yes, as I said before, the SkyHub is fusing the data with the drone telemetry. So all the data points are geotagged, so georeferenced effectively. So you get some nice pretty pictures of where your drone's been and where all the boom is. So it's all done by SkyHub. Yeah, the programmable flight route, yes, it is. It's all done with UGCS Pro and in combination with CPM. And yeah, again, I'll cover that a little bit a bit later. Power supply, again, we provide the power to Falcon via the 12-volt supply from the SkyHub. Again, as part of the kit that we sell, that comes with all the cables, so it's not something that you really need to worry about. This will all be provided for and explained how it all fits together. Tests at SPH Engineering have shown that they can still get fairly decent readings as high as 8 meters a second. Again, like I said, this is personal choice. I think once you do some testing and you realize what you're able to get at certain speeds, you can then make that call as an operator to say, we're going to fly at this speed, we're going to fly at 5, we're going to fly at 6, or we're going to fly, or whatever works for you guys. So that's really up to you. Laser wavelength, it's safe for humans. I mean, I'm not going to profess to be technical in this area, but it's the class of laser that it's using is safe for humans. You just shouldn't look into any laser light at all. It's just common sense. But on the whole, it's safe for humans. Operating temperature, not much. The Falcon 2 is not much different to the Falcon 1, which is still, a really wide envelope of operations. So in the UK, there should be absolutely no problem. And as long as your drone is weather resistant, so for example, M350 is now IP55. The system is rain resistant. The SkyHub now has its own caps on, which keeps rain out. There should be, in kinds of very, very light rain, you should still be quite confident. You can, as long as it's not really tipping it down, there should be not, you still could get away with some data. Wind envelope, yeah, I mean, people who are pilots, it is still quite a compact system. It's not like having an R4 magnetometer on the drone where you've really got to be, a lot more vigilant. But again, this is down to the pilot's choice, well, how, you know, and also his risk and what he wants to be doing. If the drone is moving about a lot, that's not going to be great for the sensor. So just ideally light wins, and that's good for the actual collection of data as well. External unit dimensions, the system itself is very compact. The detector weight, so the actual laser is, you know, it's I think it's just over 3 kilograms. But the whole system weight, when you add in all the bits and pieces, is a kilogram. And I will touch on what that means for flight time a little bit later. Question that I get asked a lot about is calibration. So that's why I've just got this at the bottom. So calibration is automatic. Every time you start the system up, the system goes through its own automatic sort of calibration process. And that's useful to know. And Iman, yeah, so you don't need to worry about calibrating it. It's all done automatically. So a little bit about configuration and setup. I wanted to get across really how quick this system is to set up and configure. I've set it up a few times, and yeah, I mean it's rapid. There's a chap there, Steve, who's putting the Falcon together. Taking him probably 15 minutes. But the first stage of setting this system up is essentially make sure you've got the software on the 3 bits of software that we spoke about, and you can see them. It's all integrated. You would have to pretend that the UGCS is on and it's working on the controller, but it's a snapshot I've put on there. But you can see that the UGCS Pro is got the root on screen, and on the left is with all the blue boxes. That's the CPM or Custom Payload Monitor, and that's the bit they all integrate together. And that software is, you know, that actually is just probably less than a minute to get all set up. It's a very quick process. So in terms of what it looks on your screen, once you've set it up, you can see that you've got CPM to the left-hand side of your screen. Just imagine this is your screen that you'll have on your laptop, let's say, when you're out on your desk. On the right-hand side, you can see there we've got a landfill site and we've got our route. And on the left-hand side, we've got our system that's showing our CPM, which is showing the altimeter height, what the altimeter is reading, what our target altitude is. And it's also showing the gas detector. In this case is the Falcon, and in this particular case we have the anemometer as well, which is showing just the output at the moment being shown here is just its wind speed. But like I was saying earlier, the new FD Technologies system is able to provide bar pressure and also vector as well, or wind direction. So there's other data being collected, but the live feed is just giving you the wind speed. The only other thing here that is probably worth a note is that speed and flight plan is done in UGCS Pro. It's only the target altitude and the safe altitude at present that we set in CPM. So it's a combination of the two, but it's a very simple system. Once you've used it a few times, it's child's play. Then we've just got to connect up the hardware. So in the hardware, we have an OSD connection, and you can see the bottom left-hand corner. We've got the OSD connector with its new lights. The new version has 3 lights, and that gives us indications of at what stage its status is. Is it fully operational? Is it communicating to the different systems? Are they talking to one another, and so on? Which is a nice touch. And then we connect in, as you can see here, we're connecting in for telemetry at the top. This is this black cable, and we're also connecting in for power into the side. And that's how we're powering up the Sky Hub. Again, this is all all comes as part of the kit. It's not something you have to think about too much. Connecting in the tube train following, you can see now we've got a yellow cable that has appeared on the right hand side above Sky Hub. That is where we're connecting in this true train following radar, which you saw on our drone picture, on the leg on the bottom left. And so we're now feeding the Skyhub CSV with and logs with the radar data as well. So and obviously controlling the drone as well. So that's how we're connecting that up. Once we've done that, we'll move on to the third stage, which is just to connect it to fasten Falcon. You saw Steve at the beginning fastening his Falcon into the bottom of his M600. It's not that different for the M300 or M350. It's connected it with its bracket, but the connections again are quite straightforward. We're connecting for power and we're connecting in for data. So there's two cables coming from Skyhub, one for power, and we have one for the data exchange as well. In this case, we use the USB for data exchange, yeah, I think the new Falcon is a Type C connector for power. Again, it's very simple. It once you've done it a couple of times, you can roll it off really quickly in the morning. So data access, measurement, validation, and quality. I could have made that a bit smaller, but I wanted to make sure I got everything in the slide. So getting Falcon data. So what? Some important notes. What you can do. Well, in Skyhub, there's a couple of things you can do. One of them, which isn't actually shown on the screen, but what you can do is although Skyhub will take 2 readings, or Falcon will send 2 readings to Skyhub per second. There is actually 10 readings per second, and you can play with that in Skyhub of how much data you want. And so that's the first thing to say. The second thing to say is you can also fix you can also take into account the background reading as well. So in Skyhub, you can say, well, the background reading is X, so we're not worried about that. We want it above that. So any data that we get coming in is from 0 effectively, because that is background. So you can be a bit clever with how the data comes in. So that's pretty good. I mentioned before about live data, and there's a nice picture here on the right hand side, as you can see, and it's an extreme case, but it's a really good case because it just shows you that the live data is coming in, and you can see that the really high reading of methane in a particular area there. That's a live feed, and I know that some customers that I've sold kits to, they're talking about using some fancy Python, taking that data, that actual live data, and using that live data to do things. Yeah, so there is scope for working with SPH in regards to creating another solution or something that will work for you. It may be something you can do internally anyway. But yeah, we've got that data, that live data feed. The CSV for GIS processing is downloaded at the end. When you've landed the drone, you've got options. You can either download it directly from Skyhub, just by logging into the Wi-Fi, into its Wi-Fi, and then going into the download section. And there's other ways of doing it as well. Again, in the training that we do with you, we'll talk about how we use other management filing systems to actually go into the system off your desktop and so on. So you can actually have Skyhub on you don't have to have it, for example, linked up to your drone all the time, turning it on and turning it off. You can actually just take it off the drone, power it separately from a mains, and just go into it via the Wi-Fi and download the data at your leisure. And that's something that we cover in your training. So it's that there are other options for that. But the main thing that I wanted to discuss, just to say, is that CSV for GIS processing and the log file types that are used for the per-gun processing software, they're downloaded at the end in one of those ways that I've just mentioned. But we also have the live data feed as well. So if you've got somebody looking, they can see a live data feed. There's no reason why you can't say, hang on, guys, we've got to go back to that. That's a major breach. For example, on a landfill site, you have a major breach. Let's go back and have a look at it. So that gives you that flexibility and to be able to move around your area, even if it's if you see something that's really important, you can go back to it. Okay. So I mentioned earlier about parts per million times M. So the way that one of the reasons why we use ppm times M, the main reason is because of the science of how it actually works. So the way that we need the column, we fire the laser through the column, and then we then take a reading at parts per million times meter column, that distance. That's how the system works. However, it does give a lot of benefits. So the idea of having a guy on the ground, he's doing his annual survey, he's walking around a landfill site, or his waterworks, whatever, and he's getting his readings. Well, he's only getting readings in the top 5 meters. That's where he's only. But if you've got any wind at all, the betting is that plume is actually moved with the direction of wind, and it's probably moved diffused upwards and out and starting to expand higher than 5 meters. So being able to take a reading from above and to be able to get readings at for all of that distance is actually a really good thing. It's a much more accurate way of looking at how much methane is actually there. So hence why you'll find that in a lot of cases that I've been involved in, flying above or at or around 15 meters is usually what people do, and it gives them that 15 meters of readings of what's really down there, as opposed to this guy at the bottom thinking that there's not that much there, but it's because he's missed it. So that's an example, a good example of why we use the ppm. Well, we measure in parts per million times m. Right, so data validation. I thought this was quite an important slide to put in, because you're not going to get 100% data quality, top data all the time. You've got different environmental conditions. Your drone is turning at the end of lines, and there is, again, during training but you are kind of explain what you need to do at the end of lines and all that kind of thing. But it's not for now. But what I wanted to show is this gas status coding system that is in the Falcon as standard. This means that you can quickly, certainly when you're looking through the data, you can quickly get rid of data that is bad, that is not, it hasn't got a good level of quality. So using this coding system, if you're getting all ones, then great, which is what we've got here. It was obviously quite a nice day, not too much sunshine, but yeah, it's a really quick way of looking through the data. Anybody who knows Excel, it's very easy to go and take that out and then process it in the way that you want to. Saying that, ideal conditions for flying this kind of equipment is, overcast, dry conditions. So try and stay away from rain. Try and stay from snow, sleet. Not always easy in the UK. With a light crosswind. So light crosswind. So being able to have that plume move in a direction is not a bad thing. That's actually ideal conditions. So so hopefully that gives you sort of an understanding of how we validate the obviously filter or you can filter the data, and you take out the for example data which is not good and not useful. So next slide. So again, data quality. I mentioned earlier that the Falcon takes 10 measurements per second, and it calculates an average, and then it provides 2 data entries per second. And I also mentioned that those 10 measurements are there, and that SkyHub has. There are play markers. You can sort of play with the data a little bit in Skyhub, and so that's something to bear in mind. But yeah, to get the best quality, from my experience, flying at 2 meters a second is I've seen some really good high quality data. You don't get many data points that are not the right number, and just to sort of say that, to give you an overview, that with a 1 kilogram total payload weight, you should be able to, let's say 40 minutes. You should be able to get 40 minutes in good conditions. Light winds or not too windy. You should be able to get around 40 minutes flight time. So you should be able to, with a 5 meter. If you look at the guidelines for this equipment, 2 meters a second at 5 meters swath off, 5 meters between survey lines, you should be able to knock off 2.4 hectares with that before your first battery change. So that's pretty impressive. I mean, that's really good. And again, as I said before, you can fly that. It's about, you can do your trialing. You can see what works for you, your guys for your operation. You might actually find you can fly it faster than that, and you're doing more hectares. But this is just an ideal. So just something to bear in mind, that when you start out, it might be that this is where you aim for, and then you can either work up or work down. But yeah, gives you an idea of flight time and what kind of hectareage you should be able to knock off. The ideal situation is that you fly a grid, but I've never really, grids are great if you've got lots and lots of time. When you've got a really large area, like a really big landfill site, then the data quality is still very good with single lines. So yeah, again, this whole single line versus grid approach is covered in the training and all those pros and cons. So it's not something that you need to worry about. Detection, mapping, and flux. Right. Well, this could be slightly controversial, but I wanted to put this in because I wanted to touch on the discussions that I'd had with the Environment Agency, and nothing heavy. It's just that they're inquiring about the technology and my work with the University of Manchester and over the last couple of years. I just wanted to give some kind of indication of where we were now with this technology and where we thought it was going to go. So if I get a call from the Environment Agency afterwards to say, look, what then that's on my head. But I wanted to say something. Anyway, the first thing I want to talk about is just to give you an idea about applications. So kind of the applications that you can use this kind of technology for. Look, a lot of these I've had inquiries for. So oil refineries, we kind of, everybody knows, where you can fly over an asset, then good luck with that. But usually it's not. It is an application. Just recently, actually, had an inquiry from European company for doing mapping methane from shipping in ports coming in and out, gas terminals, chemical and petrochemical facilities, gas pipelines. Part of your training is to be able to do open source and closed source detection. So gas pipelines being the closed source under PSSR regs, and also your more open applications such as landfill sites, sewage works, peat, etc. And then you've got all these other things. You can see them all on the screen. I'm not going to read them all out, but there's a good kind of list there of all the kind of areas where you can use this. Actually, one of the figures that I didn't put up there, because it's a long acronym, is it's to do with land conservation and methane and I guess budget mapping of peatlands is kind of part of that. But that's an area that also the Environment Agency are really looking at carefully. Anyway, there's some really good ideas there of if you are thinking about this and maybe you've got some applications, you can start looking around and go, actually, we can use that to map that whole facility, and then we can take somebody in with at ground level and go in with maybe with a an optical gas camera and really hone in on exactly where everything is. So there are some good examples there of where the system could be used. Here's a couple of outputs I've got from the software that Program Swiss, the OEM for the actual sensor, provide. You can see that there's a mains gas pipeline, and the Pergam has detected the rough area of where the gas is coming from, and then they've sent people in with gas monitors lower down on the ground floor to actually pinpoint exactly where that is. So it's again, it's been a combination of technologies. Again, here's another one, a landfill case where we've got a breach in the landfill, sort of, if you like, the undercovers that keep out the bad stuff from leaking into the surrounding water table and so on. There's been methane coming out of that breach. It might have been made by some kind of tractor or digger or whatever, but that needs to be sort of sorted out. And again, the if you're clever with how you show the data, then you can sort of perform what I call asset integrity action. And that's my next slide, actually. It's about taking this data and giving you an example of how it was used. So here's an example of where I think we are right now. Okay, so I think this technology right now in detection and mapping, pre kind of quantification, kind of flux kind of stuff, I think we're in a situation where we can empower operators to make repairs, plan upgrades and retrofits, and change policies and procedures. So what you can, in this particular case, what we've got is we've got a landfill site. We had an orthomosaic flown of the landfill site. We then overlaid the plume map of the methane readings over the top of that plume, over that orthomosaic, and then we overlaid the CAD of the actual facility itself. And so, you've got you've got wells, pipes, you've got generator, diesel gas generation facilities. You can map that that asset footprint with the plume, with an orthomosaic, and really start to get some context. And I think that's really where we are right now with this technology. It's really useful. We are kind of pre-flux, pre-quantification, but it's still really useful stuff, and it can help with companies who are trying to do the best they can to reduce their emissions and uphold their ISO accreditations and permitting and so on. So yeah, in this particular case, we were utilizing the CSV export into a GIS, and everything was just layered on. So again, it's if you've got somebody within your business that does that kind of, I mean, there's plenty of businesses outside, that specialize in this area, but tends to be within the business, the operators themselves. They can really get some, some really good context and make some real differences to their operation. So that's where I think we are today. This is where it gets interesting. So tomorrow, I think that I had a call with the University of Manchester only a few months ago, maybe a bit more than a few months ago, but I think they were talking about 12 months before they were able to provide an approach that uses this technology. So at the moment we're mapping, but mapping and detecting, but yeah, we will. We're hoping with this new development of flux calculation, this software that other, not just the University of Manchester, but others are putting into place, we will be able to move to that. So yeah, quantification. I just have some bits and pieces here. You'll all be aware of COP26, 27, 28, more of a push to for companies to engage in 14064 and being able to increase the operations, decrease the emissions, and have better better asset integrity management. So that is the idea behind the Falcon is that when we see this quantification ability, or this software that allow us to take the data, we can then move into this next stage of regulation. So I talked about the Methane Action Plan earlier, and as part of that, and just to cut this slide right down, so many times coming up, getting on, just to cut it right down, this as one of many other technology approaches would be looked at by, or it has been and is being looked at by the UK regulator for how to monitor and to help companies and organisations meet the requirements under certain regulation, permitting, and to reduce their emissions. So what I'm essentially saying here is that this TIDLAS-based system that will allow quantification using using flux approaches will it will be one tool in the toolbox for the regulator to say, right, actually we've got a number of ways of quantifying the emissions, so we can now go and regulate that. So I'm not suggesting that we're the only show in town. We're not. There are many others, but the Falcon is just one of them. But it is a very accessible. It is a very accessible way of getting quantification, because it's low cost. Lots of people already know the technology, and it's commercially available. You can take a commercial drone, put a Falcon on it, put an anemometer on, like you can see here in front of you, and you can then fuse the data together, and you can then output that into this software that will calculate the flux for you. It could be grams an hour, grams meters cubed, whatever, but it's an actual quantification. I just really, as I've said, here's a few more points, basically, just to give you sort of an overview. This is in the slide pack, so and also this video will be on YouTube, so you can go to it anytime you like. But it's just a little bit about what is flux. It's a way of quantifying using the existing data that we get from Falcon, with data from the anemometer, which will fit on as well, and then putting that into a piece of software that will give you a grams per meter cube, grams per hour reading. So we're going from a point of just mapping and detecting a mapping to a quantification stage, and that's really what I'm trying to get across. Today, detection and mapping. Tomorrow, hopefully within 12 months, we will have a quantification, it will be a quantification method. So quick JBUS supply, all of our kits, as I said, you'll get training on all the kits, how it all sets up. We'll take you through all your trialing. It's not just about here's some equipment and off you go. We will do the full wrap with ongoing service as well. So if this is something that you're really interested in and you want to move forward, then you need to be reassured we're with you all the way. It's not just about giving you kit and going off you go. We'll be with you all the way, and we'll make sure that we support you through your trials. So that brings me on to drone GIS. I've probably got about 10 minutes left, so hopefully I've not killed it too much. But yeah, I'll hand this over to Alexia now. That's my kind of, hopefully you've got a good understanding of what Falcon is, about what it can do today and what we might be able to do tomorrow, all the components. If there is anything else that you want, please make sure that the questions come in. But Alexi, I'll hand it over to you.
Okay, thank you, Jonathan. Hello, everyone. So I will just quickly clarify about main idea of Drone.js platform. So as you can see, this solution is available on premises or cloud-based. So idea is to store data, visualize data, and share data with your team or your customer without any specific GIS software. So as you can see in the name of our platform is GIS software. So you can visualize a lot of different data, not only from the Falcon. So you can visualize data from magnetometer, from echo sounder or sonar sensors. So main idea is that you upload CSV file on in your Drone.js account, make quick processing, and then you will be able to copy the link and share, send this link to your customer, and he can see a quick report about get your data and made survey over gas facility or landfill. So yeah, main idea of this platform is help to organize all data, gather it from different places, so and you can easily filter data by dates or by place, so and make annotation as well. And there is few options how to share result. You can, as I mentioned, you can send the link, or you can create report in PDF with more detailed annotation about the survey which was made over customer area. So it was shortly. So
Okay.
yeah, of course, yeah, it's now it's officially public available platform. So this is a first iteration. We still proceed to work over some feature. So, but if you are interested to see how it's work, you can reach out Jonathan, and we can organize separate meeting and show you in details how it's work. Because we need to show how it's work now, we need to spend maybe 30 minutes, additional 30 minutes to show in this webinar.
Yeah, I mean, it's essentially what I can see here is, or well, I know actually, is that you're taking the data from the CSV data from the drone, and you're essentially sticking it in a GIS and being able to provide that, reporting that in a clever way to clients, essentially, aren't you?
Yeah.
You're taking out the validation, for instance, that we mentioned before. Is done all automatically within Drone GIS, effortlessly, essentially. So it's taken a lot of the hard work out. But as Alexi said, this software is available. It's an additional tool for those people that want to be able to provide good reports to their clients in a very easy way. It's not something you've got you might not even have this kind of thing in house, but you're looking for a solution. It might be worth having a discussion outside of this to just to understand what the capability of this system is and how it can integrate with your existing systems, or how it could be used in your existing process. So that's really what this main message, this slide at the end, is all about. It's just to make people aware of this software, reporting software, and how it can be used to maybe just give you that shiny finish to your complete service. If, as Alexi said, if anybody has any questions, or you want to know more, or you would be interested in knowing more about how this system actually works and how it could maybe work in other areas of your business as well, not just, as Alexi said, methane, but if you're involved in other, like magnetometry, for instance, then it could be another system, other areas like LiDAR and so on, it could be really quite useful to you. So
Exactly.
yeah, okay.
Yeah, just one more thing. We use our Drone.js platform for internal tests with different data. And one more thing, which is quite useful in our opinion, you can send the link with GPS coordinate of the leak of methane leak. And for example, ground crew can use just a smartphone to open this link, and using smartphone GPS, he can find this leak without any additional tool, just to use smartphone and browse in the smartphone. And you can see on our YouTube channel how it's work in real lives. You just open a link in the browser on your smartphone and switch on GPS and move to the location of the methane leak. So it is quite important for double check.
Cool. Brilliant. Thanks for Alexei. Thanks for that. Let's see if we hopefully we can I can understand what I'm doing here. I think I've got to unstop. Yeah, okay. That's good. Okay, well, I don't think we've got any questions. So you know, we are 50, it's 10:57 UK time, so we've actually I wasn't sure whether we were going to make it on time. I thought we might run a little bit late, but that's turned out okay. As I said, if you have got any questions afterwards, please send them in. I know what it's like. You come out of a webinar and you want to say something, but you're not quite sure. You get your head together, and then it comes in later. So by all means, send any questions you've got. Send them into info@jbuas.co.uk. We will get them back to you within 2 hours, essentially, if we can, in regards to, you know, the sort of first level. If it gets more complicated than that, then yeah, it might be a little bit longer, but we'll do our best for you. But thanks, Alex. You know, really appreciate your time today. Thanks everybody who's come on the call. As I said at the beginning, this is being recorded. We will have this up on our YouTube channel. I'm very conscious that some of the slides I went over very quickly, certainly at the end, because we were running out of time, and I didn't want Alexei to have no time at all. But the slides, you can run through this presentation at your leisure on YouTube, and if you want a copy of the presentation, then please get in touch. I'm quite happy to give you a copy of it. So thanks very much, everybody. We'll end it there. I hope to have another webinar on another new piece of equipment, a new sensor soon, and look out for emails on that. And I look forward to seeing you then. Thanks, everybody. Take care. Bye-bye.
Bye.